Woo-hoo. Oh yeah, I'm mad. Mad, mad. I'm really, really mad. Mad, mad. I'm really, really mad. Okay, people. It's time for another funky math lesson with you know who today. So I got a couple of knock-knock jokes for you to get started today. So knock-knock. How will you know if you don't pay attention and learn the lesson? Knock, knock. Water. What are you doing answering knock-knock jokes right now? We got math to do, people. We got math to do. So here we go. All right. Mad. Okay. So this is tying back into our last lesson where we're talking about all our mean, median, mode, and range stuff. Okay, so MAD actually stands for mean, absolute, deviation. Now, I have uploaded this page for you guys. Okay, so you should have that, or if you're working on the paper packets, okay, if you picked up one of those, you should have this in the packet. Okay. So basically, I'm just going to run through this real fast because I know you people can read. But what we're basically doing is we're figuring out the average distance each data point is from the mean. Okay, so we're finding out how far every one of the numbers is from the mean. So first thing we're going to do is we're going to get the mean for the set of data. Then we're going to find out how far each of those are from the mean, and then we're going to get the average of those distances. And that will give us the MAD. So there's a nice little example box down here you can look at. But we're going to work through one together here on this sheet, okay, on mean, absolute, deviation again. So this is, okay, basically how far away each data point is from the mean, okay. The average distance each data point is from the mean. Okay, and it is going to be a positive answer because we're talking about the absolute value of it. Okay, so the answer will be positive. So the MAD will be positive because it's a distance. Okay, the distance away it is from zero. So when we talked about absolute zero a long time ago, okay, it's tying into the same thing. So the MAD will be positive because it's a distance. So no negative distances. Now we may get some negative numbers, but at the end it's all going to be in a positive amount, okay, because it's a distance away from the mean. All right, so you're going to have a little sheet like this in your packet. Okay, this one's a little bit different. I'm using a little bit different numbers just because I want to show you how it works. Okay, so these are going to look really similar to what you see on the packet or in the PDF that you're going to be working here later. So first thing you do is just take all the data and you can write them down in whatever order. If you want to write them down from least to greatest or whatever, but on this first one I'm going to do with you, I'm just going to write down the numbers. Okay, so now we're going to take and find the mean of those numbers. Of course, you can see we've got 5 numbers, so I'm just going to put them in right here. Scoot this over so you can see it a little better. Alright, so we got 10 plus 7 plus 13 plus 10 plus 8. Okay, so there's my 5 numbers. 1, 2, 3, 4, 5. Alright, and the sum of those numbers is 48. Okay, so right up here I'm just going to write 48 divided by 5. And let's see what the mean actually is. Alright, and it came out to give me 9 6/10. Okay, 9 6/10. If these ever come out to be some super big long number, let's just take it to the hundredths place, alright, just like we've been doing. And this one, of course, we don't have to worry about it because it's going to the tenths place, but if they come out longer, let's take them out to the hundredths place. Alright, so right here, I'm going to write down the mean that we just got for all these. Okay. Now, we are now going to do subtract, okay, because difference is a subtract word. Okay, that is what difference means. So we're going to subtract either the data and the mean or the mean and the data. I'm going to make sure we get a positive amount for each one of these, okay? So if I do 10 minus, if I slide it right there, 10 minus 9.6, we get 0.4, and I got a couple of those on there. So that would be a 4/10 for that one, and a 4/10 for that one. Alright, and here's what I'm talking about. If I do 7 minus 9.6, that's going to give me a negative number, right? Negative 2 6/10. So over here, in a second, you'll see where we're going to write all these with a positive value. Okay? So the next one would be 13 minus 9.6, which is 3 4/10. And I'll go ahead and do the 8 minus 9.6 while I've got it sitting here. And you can see that's going to be a negative. So 13 minus 9.6 is 3.4. And then 8 minus 9.6 is a negative 1.6. Now we're not going to use any of those negative numbers. We're going to do the absolute value. So over here, I'm just going to write down all these in a positive fashion. Okay, 0.4 4/10, 2 6/10, 3 4/10, another 4/10, and of course that one's negative. So since we're talking about absolute value, we're going to change that to a positive 1.6. Okay. Now we've got all our little distances here that each one of those numbers is away from the mean. Now we're going to find the average of those little numbers. Okay, so I'm just going to take all those little differences you see we've got right here in the positive value column. So 0.4, add them up, gets a sum. 0.4 plus 2.6 plus 3.4 plus 0.4 plus 1.6, and that gives me a sum, okay, when I add all those little differences up there, of 8.4. Okay, how many numbers did we have is what the count thing means. Of course we had 5 numbers, 1, 2, 3, 4, 5, or you can count it here, 1, 2, 3, 4, 5. So now we're going to do 8.4 divided by 5, okay. So I've already got my 8.4 here on the calculator, so 8.4 divided by 5, and that means the mean absolute deviation, or the MAD, is 1 68/100. So right there, 1 68/100. Okay. So data, get the mean, subtract all that. Subtract each number from the mean. If you get a negative, come over here. We're going to put it in the positive column because we're talking about absolute, which is the distance from 0. Add all those little distances up right there. Get your sum. Divide it by the count. All right. Let's do one that's got a little bit bigger number set to it. Okay, so let's come down here to this next one, and let's do one more. Okay, this time I'm going to put them in order. This might be a little bit easier since I got more numbers. I'm going to put them in order from least to greatest to start with. So let's start with the 70s. It looks like we got the 74 and the 75. I said 74, 75. I got a 77 and a 79, and then an 81 and an 82, and then we got 85 and an 87, and an 88 and a 90. Now I know this looks like it's a lot of work, but I'm trying to get you just, in this little box to give you a good visual on how it starts with. Once you get the hang of it, you don't have to keep doing it in these box type things, but just for these first few, just trying to help you guys see a good visual that's going to help you understand how to go about finding the MAD. Alright, so let's get the mean here first. 74 plus 75 plus 77, 79 plus 81. Oop. 81 plus 82 plus 85 plus 87 plus 88 plus 90. All right, let's make sure I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, and that would be a sum of 818. Okay, so 818 divided by 10. We got 818 divided by 10 gives us a mean of 81.8. Alright, so now we'll write that down in all these right here. 81.8, 81.8. I'll do it as fast as I can because I don't want to bore you to death. So just write all of them down in there as fast as you can get them in there. 81.8, 81.8, 81.8, and 81.8. Okay. Alright, so this time, same thing. We're going to take each data point, subtract the mean. If it comes out being negative, we're going to turn it into a positive over here. So here we go. 74 minus 81.8 is negative 7.8. Okay. 75 minus 81.8, negative 6.8. 77 minus 81.8, negative 4.8. 79 minus 81.8, negative 2.8. 81 minus 81.8, negative 0.8. Alright, from here they'll start being positives now. 82 minus 81.8 is 0.2. 85 minus 81.8 is 3.2. 87 minus 81.8 is 5.2. 88 minus 81.8 is 6.2. And then 90 minus 81.8 is 8.2. Alright, again, since it's a distance, all these are going to become absolute value, which means they're going to become positive. So I'm just going to write all the positive little differences over here now. So take the negative ones and write them as a positive. And the positive ones, of course, stay positive. So you don't have to do anything other than just write them down again. Okay. Alright, now we're going to get the sum of all these, and then we're going to divide it by 10. Okay, so let's see. Everybody see that alright? Okay, 7.8 plus 6.8 plus 4.8 plus 2.8 plus 0.8 plus 0.2 plus 3.2 plus 5.2 plus 6.2 plus 8.2. Let's see, 1, 2, 3, 4. Okay. Altogether, that gives us a sum of 46 for all those little differences. Okay, we had 10 numbers up here that we counted earlier, so our count is 10. So if you do 46 divided by 10, that's easy enough. It's 4.6, and that's the average distance that each one of those data points is away from the mean. Okay, 4.6. All right, people. That's how it works, okay? So I hope you are doing all right. Hope you're feeling all right. I hope you're not feeling bad. Get it? Bad. All right, I hope you're not feeling mad either. So take every one of these things, get the mean, subtract it all the way from each one of the data points. Make sure you turn it all those little differences, make sure you turn them all into little positive numbers. Don't use negatives, right? So it's the positive value column. Average all those up, so you add them all up, divide by how many you got, and you got the mad. Mad, I'm really, really mad. Mad, I'm really, really mad. Woo! 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 See ya. Come back next time for another good math lesson. Ciao. Hasta la vista, baby. Sayonara.